Okay, so everybody, oh shoot, come on. Oh, now, wait. Whose phone is this up here on the floor?
That's mine.
Find a new place for it, because I am gonna stand on it. And you do not want that to happen, so these are off limits. Right there's a plug, right there is a plug.
Come on, Abe. Abe, just stop hacking.
Where's my cord though?
He stole it.
I didn't move it either.
Oh, that was so okay, so your job was to find something for us to talk about today. So who found something for us to talk about? Kara, tell us what sheet it's on.
The one we have, we're going number 3, number 2, 6A.
Which one?
6A.
6A on pretest number 2. This is the pretest, so this is what's on your test, okay? So there's a question like this on your test. Won't be exactly the same question, but it will be handled just like this. Okay, so what do? Sign 105. Split it up into 2 special angles that add up, or subtract, add or subtract, to 105. So I heard somebody already say the most obvious was 45 and 60. So sine 45 plus 60. All right? So now I've got the sine of an angle plus an angle. So I look at my sheet, and on the sheet, there's a formula for the sine of an angle plus an angle. What is it? Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Because it's right on your sheet, okay? It's the U and the V, I think. But it could be A and B, X and Y, doesn't matter. It's angle plus angle. Over to the side, I'm gonna draw the 2 angles in the problem. So I'm gonna draw my 45 and my 60. Because I am gonna need the numbers from the picture to plug into the formula. Now, the sine of 45 is a number, right? So I don't write sine root 2 over 2, I just write root 2 over 2. And then cosine 60 is just 1/2. Cosine 45 and sine 60. Just plugging from the picture into my formula. These are multiplied, so that's going to be root 2 over 4. These are multiplied, so that's root 6 over 4. These are added, they have a common denominator, but the numerators do not combine. So I have to leave them as root 2 plus root 6 because I can't add radicals unless those numbers are the same. Okay, Kara? Did anything confuse you about that? Okay. Emma?
On the same one, retest number 2, 3A.
3A is an equation that I'm going to solve. And it is a quadratic. You notice that? So we're going to start by factoring it. So how does this factor? Tan x. What do you think? Plus 1 minus 4, that sounds good to me. Is that okay? Now, this one was already set equal to 0. Remember, if they're not already equal to 0, move things around so they're equal to 0. Then factor it. Set each factor equal to 0, so tan equals -1, or tan equals 4. the angles that give me a tangent of -1. Where will those angles be? I'm doing this factor. Where will I look if the tangent is negative? 2 and 4. Because in quadrant 2, this one's negative and that one's positive. So there it is, tangent -1. And then 4, same thing. Now, can you tell how big that angle is right there? 45? Am I in degrees? Nope, I'm in radians. So I can't use 45, I'll have to use pi over 4. And then pi over 4 is not an answer, do not write it down. The answers are the pi over 4 in quadrant 2, which is pi minus pi over 4. So 1 minus a fourth, 3 pi over 4. And then the pi over 4 in quadrant 2, or 4, in quadrant 4, which is 2 pi minus pi over 4, so 2 minus a fourth. Everybody okay so far? Now, next one, where is the tangent 4? What quadrants? 1 and 3? Tangent positive, opposite adjacent. I can draw a picture of this, okay, but is that one of my special angles? That's why this is a calculator problem, because for this part I need a calculator. So I'm gonna go to, first of all, I'm gonna go to mode and make sure that my calculator is set in radians. Because isn't my answer supposed to be in radians? And the calculator will give me it in radians if I tell it to, so I'm gonna set it in radians. Then I'm gonna press, what do I press to get the angle here? Second, tangent 4, and it's 1.33. So the first answer to this is 1.33. Because it's right there in quadrant 1. The orange one is in quadrant 3 though, so I will have to take my 1.33 and add it to pi. And I got 4.47. Whether I use a calculator or not doesn't change anything about the way I'm doing the problem. It's just sometimes I need the calculator to get that angle right there. All right, Emma, does that take care of that? All right, who else? These are great questions. Who else?
On the same page, can we do 5A?
5A. Oh. Cosine squared plus sine squared. 1. That's it. That's 1. Because anytime you have cosine squared and sine squared added together, as long as the angle is the same, I mean, you can't have 77 and 75, but as long as the angle is the same, it's going to be 1.
Okay, what about B?
B. Okay, so I need to look on my sheet and find a formula that is cosine squared something minus sine squared something. You're not going to see the 77 on there, but you should see a cosine squared minus sine squared. It's the cosine of 2 times the angle, and my angle is 77. So this is a formula for the cosine of 154. See how that works, Nyla? So on that set of problems, where it says simplify like that, those are all your formulas. You're just gonna look on your sheet, figure out which formula it is, and then you'll know your answer, all right? Who else? We can do this sheet, which is a great sheet, that's the test, but so is the review sheet, so we can do that one too, whatever, doesn't matter.
5D.
Wait, she had her hand up, so I'll get you next.
I was gonna say 2D on that same sheet.
2D on the same sheet. This is a verify. So we are going to somehow have to turn this into secant. All right, so Meg, do you have an idea? You gotta do something to get started. Do you have an idea about what we could do?
Get everything into cosine and sine.
I love it. It's my favorite thing to do. Get everything into sines and cosines. So that already is. What's this? Sine over cosine. Now, at this point, everything's in sines and cosines. So we either have to do something that's like arithmetic-wise, like factoring or whatever, or we have to do something tricky. And I think we have something we can do arithmetic-wise here. We got two fractions that we're adding. What do we do when we add fractions? We get a common denominator. So always be on the lookout for the regular arithmetic, common denominators, factoring. All right, so this one needs a 1 plus sign. And this one needs a cosine. Okay, Meg, now the denominators match, right? So what have I got up here? Let's do distributive. I have sine plus sine squared plus cosine squared. Why am I so happy? That's 1. So I have sine plus 1 over cosine 1 plus sine.
Oh, and then you can.
Yeah, remember, you can't cancel a piece, but you could cancel the whole shebang.
Yeah.
And that's gonna leave you with 1 over cosine, which is secant. All right? I know they look scary, but if you just look at them bravely, you can do this. You can do this. All right, Peter, what was your question?
Oh. 5D.
5D.
D.
All right, this is another one, this is 5D. This is another one where we just work on our formula sheet and figure out what formula is this? Well, it's the square root of 1 minus cosine something over 2. What is that? What's your sheet? Sorry, look at your sheet. That's a formula for the sine of half the angle. Well, our angle is 50. So this is a formula for the sine of 25. All right, what else? Jake?
6B on the same one.
6B you did yesterday.
Oh, we did.
We did. Let me look on the other sheet. We can do, on the review sheet, we can do 5C. It's the same kind of problem.
Yeah, that'll be good.
All right, so this is on the actual review sheet. 5C says find the cosine of 2x and we are given that the cosine of x is 4/5, and it's in quadrant 4. Keep in mind, there's two different ways that I've been expressing quadrant 4. It might literally say in quadrant 4. It also could say this, right? Doesn't this mean, also quadrant 4? Yeah, so either one of those two. All right, so let's draw a picture of that. I'm in quadrant 4. My angle has a cosine adjacent over hypotenuse, which means the other side I could find with the Pythagorean theorem, or we keep having our little special. That would be -3, negative. If you did the Pythagorean theorem, 4 squared plus x squared equals 5 squared, that would be the setup for that. And it'll work out to be -3. Okay, so I drew a picture of the given, got everything all set up. What formula am I gonna use for the cosine of 2x? 2 cosine squared minus 1. Boys and girls, you have everything you need, so use whatever version you want. There is no wrong choice, all right? Just pick one. He picked this one. This says take your cosine, which is 4/5, and square it and times it by 2. So that's going to be 2 times 16/25 minus 1. Are you following along here? It's 2/1, so 32/25 minus 1. 32/25 minus 25/25 is 7/25.
So on one like that, do you even need to make a graph?
On this one, you didn't need to. Not if you're gonna use that formula.
Yeah.
I always draw a picture of my given, because this is kind of a special situation. What I do want everybody to see though is, if the main formula, like the one that back in the days when we had to memorize all this stuff, the one that we memorized for cosine 2x is cosine squared minus sine squared. So what if I use that one? Well, look at my picture. Cosine squared would be 16/25. Would you agree with me? 4/5 squared. Sine squared will be 9/25. Well, what happens when I subtract those? What do I get? Yeah, the formula you choose doesn't matter. So pick one and roll with it. Okay, what else? F, what F? Which number F? 7F. And I put a little note there that said it's tricky, and it's tricky because when I look on my sheet, I do not see a formula that says sine, sine minus cosine, cosine. I don't see that on my sheet. Is there anything close to that on my sheet? What is on my sheet? Cosine, cosine minus sine, sine. So in other words, the opposite of this. So I'm going to rewrite this like this. Aren't these two exactly the same thing? And this is on my sheet. What is that? That's a formula for what? Cosine of an angle plus an angle. And the angles are 15 and 11. So this part is the formula for the cosine of 26. But because the problem was backwards in the beginning, it's the opposite of that. So it's really not hard, you just have to recognize that is not on the sheet exactly. Okay, what else? Emma?
For test number 2, number 3
yesterday. So let me see if there's another one like it. Well, there's not one exactly like it, but one that's close would be on the review sheet 2A. So I could actually make this one exactly like the one on the review sheet if this is what's on the sheet. But what could be on the sheet is this. Like your problem you asked about had a 2x. First thing you have to do is get rid of the 2x. Well, if I look at my sheet, the sign of 2x is 2 sine cosine. So that would be your first step. Change the 2x. You can't do a problem with a 2x and an x. So if you've got a 2x and an x, get your formula sheet out and rewrite it. So for that problem, this is what we would have done. All right? Now, where do we go from here? What happens now? Factor out a sine, and what will I be left with? 2 cosine minus 1. Don't forget the 1. If you take out the whole thing, you have to have a 1. Okay, then what do? Set them equal to 0. So sine is 0, and this one, if I skip a couple steps, can I say cosine equals 1/2 without confusing anybody? Okay, and where do I get sine equals 0 from? Circle. Sine is which coordinate? Y. Y. So it's 0 here and here. I'm in radians for this problem. This is on the review sheet 2A. I'm in radians. So what are these answers in radians? 0 and pi. All right, where is the cosine positive 1/2? Certainly in 1 and in 4, because cosine is x and x is positive on the right. Cosine is 1/2. So how big's my reference angle? 60, but I'm in radians, so 60 is 1/3. Everybody still with me? What are the answers then? One answer is pi over 3. And the other answer will be 2 pi minus pi over 3, so 2 minus 1/3, which is 5/3.
Wow.
Is that all right with everybody? Okay. What else? On the review sheet? Review sheet 4A is another verification. Just FYI, on the test, you'll have a choice of verifications. I mean, there'll be, I can't remember, 4 or 5 of them, and you'll be able to pick 2 or 3, however many. So you'll have some choice in that. Okay, so Robbie, yeah, a couple of different options. What might strike you?
In the common denominator.
I would do that, I think that sounds like a very reasonable thing to do. Secant minus one, secant plus one, two fractions added together. Right, remember we have to do something, we can't just sit there and stew about it, we have to do something. So getting a common denominator seems like a very good choice. So this one needs to be multiplied by secant plus one. And this one by secant minus one. So now they both have the same denominator, there it is. And my numerators are secant plus one plus secant minus one. All right. On top, I have two secant. Would you agree with that? That's what's on top. That's a good sign. Perfect. So far, that's exactly what I wanted. Now, what have I got on the bottom? Secant squared minus one. Look on your sheet. Isn't there something on your sheet that says 1 plus cotangent squared? Oh, shoot. Wait. It says 1 plus tangent squared is secant squared, right? So secant squared minus 1 would be tangent squared. So I've got 2 secant over tangent squared. Wait a second. Isn't that the same as 2 secant times 1 over tangent squared? Now think about that. If I multiply these two together, wouldn't I get this? And what's 1 over tangent squared? So you had to kind of be aware of that.
Does it matter if it's used in front of the secant instead of the cotangent?
No. That's all multiplication, so we can do it in any order. I know in geometry, when you did proving, you had to turn things around. We don't worry about it. If you look at that little group of Pythagorean identities, all of them have functions squared and a 1. So whenever I have something squared and a 1, I want to think about those identities. They can be very useful. You could also have changed everything into sines and cosines and gotten the answer. Would have taken long. All right, great question. What else? Jake?
Review sheet 4C.
4C is another identity. And this one is way scarier than it really is. What's 1 minus sine squared? 1 minus sine squared is cosine squared. And what's cosine squared times cosine? So again, see this? It's a 1 and a squared function. Immediately think about those identities.
I was thinking like the other way, like get a term cosine.
Okay, you can do it either way. If you did that, I would change that into cosine times cosine squared. And then cosine squared is 1 minus sine squared.
So, can you solve like each side?
Okay, you can go from left to right, or you can go from right to left. You can't do some right and some left. But yeah, it's an equation, so you can go either way. Yeah. All right. Who else? Come on, guys, tomorrow there will be great wailing and gnashing of teeth, and I don't want that to happen.
What about 3A?
Who said that? On the review sheet, 3A says solve in degrees and use a calculator. Obviously, because 0.37 is not a number that I know. So it says 2 cosine equals 0.37. I'm in degrees, so cosine would be 0.37 over 2. Would you agree with that? That's a positive number. Which quadrants is the cosine positive? 1 and 4. Now, I know I'm using my calculator, but I still need that picture because my calculator will only give me this angle right here. He won't give me the other answer. I have to figure that out. How do I get that one? Remember, we're in degrees, so the first thing we're gonna do is change our calculator into degrees. And then what do I press to get this angle? Second cosine, 0.37 divided by 2. And I got 79.34. Anybody else get that?
Yeah.
So what are the answers to the question? Well, one of them is 79.34 because my triangle's in quadrant 1. What would the other one be? 360 minus that, so 280.66. Okay, got it? Now, I'm gonna skip down to number C, because it's like the same thing, but you know what I'm gonna caution you about. What am I gonna caution you about in problem 3C on the review sheet? You gotta do plus or minus. When you take the square root, it's gonna be plus or minus square root of 5. Which means what? I'm gonna be in all 4 quadrants. Now, how am I gonna type this in on my calculator? Yeah. If this is the cosecant, then isn't the sine 1 divided by root 5? So, I'm still in degrees. So second sine 1 divided by the square root of 5. I got 26.57. Is that what you got? Okay, so how do I get my answers? One of them is 26.57. And then what? Subtract from 180. Add to 180. And subtract from 360. How's that look to everybody? Did you follow all that? So 2 things about that. If you're square rooting, if you are square rooting, don't forget the plus or minus. And if it's a function not on your calculator, you're gonna have to rewrite it as 1 over. All right, anybody else? On this review sheet, Emma, there is another, I just saw it, number 8, that's like the one you asked about. This is number 8 on the review sheet. What are we going to do with that? What's the first thing you gotta do with it? No, there's no factoring to do here. Yet, there might be, but not yet. What's the first thing we have to do? get rid of the cosine 2x. Kids, you can, without doing it graphically, you cannot solve this equation with a 2x and an x, okay? So you've gotta make those match. What do we know about cosine 2x? Lots. It's 2 sine squared minus 1. It's cosine squared minus sine squared. And it's 2 cosine squared minus 1. Cosine squared minus sine squared. Or 1 minus 2 sine squared. Alright? Which one shall we pick? Because that's a cosine, I'll pick the one that's just cosines. If this had been a sine, I would pick the one that's just sines. So there's only 2 formulas where you have any choice, and this is one of them. All the rest of them, they are what they are. And here we have a choice, so we'll pick that one. Now let's put it in order, because it is a quadratic. And then what will I do with it? It's gonna factor. So I'm getting cosine equal 1/2 or cosine equal -1. Did anybody else get that? So where does the cosine equal a positive number? I think I've asked that 15 times. Cosine is positive in quadrant 1 and 4. 1/2. This is in degrees, so that's a 60. So what are the answers to this first part? 60 and 300, beautiful. Where is the cosine -1? 180? Because cosine is x, and x is -1 in one spot. So Emma, that is kind of like the question you want me to do. All right, what else? There's a back side to that too, it's a quick review. Last page, quick review, look at number 1. We just talked about this scenario. I really want to do the questions you want me to do, but we're not going to sit and look at each other, so I'm going to keep doing problems until you come up with some. This one's in radians. What do I need to do with this problem? Just talked about it. Gotta get rid of this, okay? So you gotta get rid of cosine 2x. So you look on your sheet. What are you gonna put in for cosine 2x? 1 minus 2 sine squared.
Get it all on one side.
Could you put in something else and be right? Absolutely, but you're gonna have to do some work because ultimately you need it all to be the same function. So we can do that right away. All right, I moved everything over, so I have 2 sine squared minus 3 sine plus 1. If I subtract this, add this, does that look okay?
Yep.
Now what? Factor it. Guess it's gotta be minus and minus. Does that work out?
Yeah.
So this time sine equals 1/2 or sine equals 1. I'm gonna do this one first because my circle is right there. Where is sine 1?
Why?
Sine is y, and isn't that right here? So we're in radians, so what angle is that? Pi over 2, 90 degrees, pi over 2. Now, I need the sine to be a positive number, sine to be positive. Where does that happen? 1 and 2, because sine is y. I need it to be 1/2, so opposite over hypotenuse.
It's 30 degrees.
So it's a 30-degree angle, but I'm in radians. So pi over 6, because 30 is a sixth of 180. So the answers are pi over 6. And then this one, which is pi minus pi over 6, or 5 pi over 6. Number 3 on that quick review page is a verify. It's going to involve a complex fraction, probably, because when I look at this, and when I look at what I'm supposed to be ending up with, what's kind of your gut feeling? You gotta do something, get started, change it into sines and cosines. And when I do that, I'm gonna have sine over cosine on the top, because this is 1 over cosine. So when I multiply those, does everybody see how you get sine over cosine?
Yeah.
And then I have sine over cosine plus cosine over sine. Now, you see how these two are the same?
Yeah.
Do not cancel them, because there is a plus. You can't cancel part of it. Okay? You can only cancel the whole thing. You can't cancel part of the denominator.
Can you explain how you got sine?
Okay, it's sine over 1 times 1 over cosine. What happens when we multiply the fractions, right? Okay, now this is a mess. I am choosing to multiply everything by the common denominator, which is sine cosine. And I'm gonna see what happens when I do that. Okay, these cancel. So what's left on the top? Sine squared. That's good news. All right, these cancel, so what's left here? Sine squared.
Let's go sine.
Oh man,
Oh my gosh.
I know, life does not get much
How does that work?
more joyful than that. Might as well do number 2. I'm waiting for you to ask me problems, guys. All this is on the test, okay? All this stuff is on the test. Sine 345, what do you want to do with that one? Split it, right? And what do you want to split it into?
45 and 300.
345, that sounds like a great idea. Now, why, obviously 45, that's one of our angles. Why 300? Why is that allowed?
This is 60 degrees.
Because it's a 60-degree angle in quadrant 4. Now, kids, I don't know, some homework or some quiz or something, and it was a different number, but people were doing things like 360 minus 15. Now, 360 is okay, that's one of my special angles, it's on the circle, everything's fine. Is 15 special? No, you have to use an angle that's either a 45, a 60, or a 30. It can be in any quadrant. So your 300 is a 60-degree angle in quadrant 4, so it's fine. these are the labels, but that one's negative. You simply have to be laser focused on triangles that are not in quadrant one. Locked in, yeah, as I say, I'm locked in. All right, 45. All right, so there are my pictures of the angles that we have chosen to use. So what do we do now?
Now you do.
Now I use my formula, my sine plus formula. And what does the sine plus formula say?
Sine of 300.
Sine of the first,
Cosine 45.
cosine of the second,
Plus
was
cosine 300.
cosine 300, sine 45.
You find out about your triangle.
Exactly. And I don't write sine and cosine now. I simply write the fractions. The sine of 300 is negative root 3 over 2. The cosine is root 2 over 2 of 45. Cosine 300 is 1/2 sine 45.
Do some multiplication.
Do some multiplication.
Probably get a root 6 and a root 2.
These two can times. Don't make fun of me.
I'm not making fun
This
of
is a
you.
test
I'm
question.
making fun of that.
Negative root 6 plus root 2 all over.
It's always a root 6 and root 2.
It's always, and why is that?
Like a 50-50 shot.
Use the same angles. We always use for 360 and 45, so you're always gonna have the same numbers.
I could guess, I could see that problem and guess, and I'd probably get it right.
Go for it. All right, got time for a couple more. I don't care where they come from, doesn't matter to me, but let's go. You pick them. We've done a lot of them, that's for sure. Look on the review sheet at problem 2C on the review sheet. Now, I know what you're thinking. You're thinking, this looks pretty easy, Mrs. Ford, and you're right. It's already set equal to 0. So, what are we gonna do? Factor it. So the factors are gonna be -3 plus 1. Is that okay with everybody?
Yep.
Okay, this is why I picked this problem. The first factor says sine equals 3. I want you to think about that for a minute. Sine is opposite over hypotenuse. Can you have a triangle where this side's 3 and this side's 1? No. In a sine and cosine, doesn't the denominator always have to be bigger? So this is extraneous. There's no solutions that are coming out of that one. You can still do the other one because it says sine is -1, and we know that's going to be on our circle. Where is the sine -1? 270. I don't know what I'm in actually. I'm in radians, so I won't say 270. I'll say 3 pi over 2. 1.5 pi's 3 pi over 2. So be on the lookout for that. You cannot have a sine or a cosine that's bigger than 1. Can you have a tangent? Oh yeah, tangents can be anything, but not sines and cosines.
Sorry, you just said sine, cosine, if it's over 1.
Okay.
Why is it extreme?
There's my sine curve. How high does my sine curve go? The biggest the sine can be. Sine can't be bigger than 1. Ever.
Oh, that's 3 over.
Yeah, it's 3. Can't be 3.
So if it's 2, it's extreme.
Can't be 2. Can't be 1.1. And if you don't believe me, take your calculator out and do second sine 3. It will say error.
I really hate
Never doubted you.
All right, one more problem and then I'll shut up.
On the back side, 4A.
4A is another one of these where you have to look at your sheet and find a formula that's 2 times the sine of something times the cosine of something. What is that the formula for? Isn't that the formula for the sine of twice the angle?
Yeah.
Sine 2x, 2 sine cosine? So this is a formula for the sine of 2 times 18. So it's the formula for the sine of 36. All right, that's it. Tomorrow's our test. It is game day. And it's a big day. It's extra special game day